We have talked about ports and the communication channels, but we never really got into exactly what is going on inside the port. Your standard web traffic is sent over port 80. Now, port 80 is just an open line of communication for HTTP traffic. It doesn't wrap any type of security measures around the line. It is simply passing human-readable, plain text packets back and forth over the open web, the proverbial cloud we call the internet. An attacker, either on purpose or by accident, can plant themselves anywhere along the communication path and snoop on your data. The communication path includes, but is not limited to, your home Wi-Fi, your ISP's network, any of the backbone hops along the way, including the network where the server resides. Banks, shopping sites, and other web applications that host very sensitive information knew there would be no future on the open web if something didn't change. That's when SSL certificates came into play many years ago. With SSL certificates, keys are swapped, information is encrypted, and the communication can go on without having to worry about anyone listening in on your conversations. For the purpose of what we're covering here in this course, Zap is playing the role of attacker and wanting to get a hold of the information being transported. We're going to place Zap on the line of communication, but how do we get between a browser and the server if the open line of communication is encrypted? Simple, we'll decrypt it. Wait, what? Well, to be clear, we're not decrypting the established secure communication between the browser and the server. What we're going to do is have Zap set up that secure channel to the server. Then Zap will use its own trusted certificate to communicate to the browser. And because the Zap cert is in the trusted chain, the browser will just accept that it is okay to communicate to the server over this line. Zap will talk to the browser, receive the encrypted traffic, decrypt it, manipulate it, re-encrypt it, and with the second certificate, push it onto the server. What I just described is your basic man-in-the-middle attack, where the attacker is trying to intercept traffic by placing themselves in the middle of it, without being caught. That's the simple explanation, but there's a lot more involved. Let's look at how to get this certificate set up. In this demo, we are going to walk through the steps of generating and retrieving the certificate from Zap, then installing it into the Trusted Root Certificate Authority for the browsers to know it is okay to talk to Zap. Okay, so starting in Zap, we'll create the certificate that will be imported into the Trusted Root Certificate Authority of the computer. This certificate is what will allow Zap to sit between the browser and the server on encrypted HTTPS calls and be able to actually read the packets being sent back and forth. Like most settings in Zap, they can be found in the Tools menu. Then down to Options. Now this time we are going to scroll down to Dynamic SSL Certificates. We're now inside the menu where you can create the certificate that will be used. Now keep in mind, this is another one of those one-time deals. We only have to create the certificate once and is good for exactly 1 year. After the certificate expires, you'll need to generate a new certificate and import it again, but until then, every HTTPS website you review with Zap will be open and readable. Now the first thing we want to do is click on the Generate button to generate the certificate. From here you have two options in order to install the certificate. You can click the View button to open the certificate, at which point you'll see the Install Certificate button. Or if we get out of here and back to the Dynamic SSL menu, you can click Save and store the certificate. Now after you save your certificate, and in this case I'm simply saving it to my desktop, in order to install your certificate, you are going to navigate to the spot where you saved it and right-click on that file. Click Install Certificate. Next. Now make sure you check Place all certificates in the following store and browse to Trusted Root Certificate Authorities and click OK. Next. And finish. And that's it. You are all set if you are a Chrome user. If you're using Firefox as your browser or plan to use it when testing with Zap, you will need to follow some additional steps to install the certificate in the store held locally inside of Firefox. In this next demo, we are going to walk through the simple steps of importing the certificate. So let's start inside the Firefox browser. Now the reason I walk through saving that certificate to a central location, and not just the easier path of viewing the certificate and installing it, is because we now need that file in order to import the certificate into Firefox. See, Firefox maintains their own certificate authority store separate from the OS store, so we need to take a second pass and import it into here as well. If you do not use Firefox, you can skip this demo, as the steps here will not affect you. We're going to go up to the menu bars, down to Options, click on the Advanced menu, click on the Certificates tab, and we'll see in there View Certificates, and once we open that, you'll see Import. Again, this is why it was important to mark where you save that actual certificate file. If you remember, I simply placed mine in the desktop. So I'm going to select it, click Open. Now be sure to check the box to trust this CA to identify websites, and finish it off by hitting OK. OK, and now we can exit out of here, and we're all set. Here are the steps once again if you need them. Simply pause the video, install the certificate, and come back. In the next steps, we are going to walk through some of the legalities of this and how to set up a playground. But really, if you are ready, you now have all the basics down to head out and start testing that new web application you are working on.